So now we'll be working on the next method. So we'll be working on the public void Deque front method. So we'll just go under this method in QFront. For some reason these are in the same these methods are in the same method. So we'll take this one, we'll cut it. That's the else, that's the method, that's the class. What's this? Just an extra. So we'll just double check that's the class, that's the method, so we'll take that method. We'll move this brace up. Then we'll put that there. That should be fine. What's up with this? It's asking for another one. Okay, so we will put another one here. Another bracket. Move that down. So under this, we'll take, we'll start writing the next method. So public void Deque front. Say if head equals to null and tail equals to null. Then we can throw an exception, or we can just return null. So here we'll just say system dot, instead of throwing an exception, we'll do this. We'll just say that it's empty. And then we'll just return null here. And if it's not empty, we could change this to T, I guess. Actually, that would ruin the interface. So we can just throw an exception. So we don't have to change all this. So we'll just say whoops. So we'll just say throw new empty collection exception. And we'll just say link deck. And here we'll just put throws empty collection exception. And below here we'll say else if count is equal to 1. So what we're doing is we're dequeuing from the front of the deck, so we're moving the first element. So we'll say head points to head.getNext, and tail points to tail.getPrevious. So head points to head.getNext. Tail points to tail.previous, count minus minus. I feel like we don't need that line. So head just points to head.getNext. I feel like this one, it's unnecessary. Spell that wrong. So then we'll just say count minus minus, and we'll come back and check. I feel like we can just maybe set a pointer to the other element. So we can say, so basically if count is equal to 1. Actually, maybe this might be correct, because if count is equal to 1, so that means there's only one element in the deck. So that means head and tail are both pointing to 5. So basically, both elements are going to get set to null. That seems like what's really happening, because if there's only one element, then there's going to be null on this side. And if that's the head, then there's going to be null on this side. So if 5's the head and the tail, then 5's just going to point to null, because heads is 5, so head's going to point to head.getNext, which is null, and tail is going to point to tail.getPrevious, which is null, and count's going to decrement by 1, so it's going to become 0. So it seems like that's one way to do it. You could also just set head to null, tail to null, and decrement by 1. That seems like it could also work. So I guess it is needed. So you could have maybe just said head points to null, tail points to null. Or you could have done it in one line, like head points to tail points to null, if you really wanted to, but I prefer this way here, it's more clear. So if count is not just 1, then we're going to say here else. So we have else, if, then we'll have another else underneath, so they're nested. You keep track of them by indenting in, like that. So this else goes with this if, and then this if. This is like else, and then this if goes with this else. Pretty much going to be using these in almost every programming language, so it's best to learn it. So we'll just say linear node of generic type T here. Temp node points to head. So we're going to create a pointer. Name temp node or temp. Then we'll say head.getNext. Head points to head.getNext. So head points to head.getNext. Head points to, so if, let's just say there's 5, 6, 11 in this. So if you want to deque the front and take away 5, then we're going to say head points to the next element. So head's going to be this element. And we also have a previous reference, so remember if head was 5, then its next is 6 and its previous is null. So if we say head point to head.getNext, so head's going to be 6 and its previous is going to be 5, so we're going to set its previous to null since head has changed, so we'll say head.set previous to null. This seems like it's as efficient as it can be. Then we'll say temp node points to null just to make that eligible for garbage collection. Then we'll count minus minus, so decrement count by 1. So that seems the most efficient. So it seems like this way is similar to what we did here. We don't need to traverse it for enqueued to the front. We don't need to really traverse. I don't know why that bracket's like that. We can just change it to that after. We can try that. Can move this below here. What's going on with this? Okay, that's fine. Save that. It keeps auto formatting the brackets. It's really annoying. I don't like that. I don't like it like that. Some people might. That's just the way I always do it in every language, so it just helps me keep it all organized because I know where to look. I don't have to look for a bracket here and then look for the ending bracket diagonally, right? I can just look at one bracket and then just look that the bracket's right under it. I don't have to look across code like if there was statements all the way out here and there was a bracket out here, I don't have to be looking for one over here. So it's kind of, I find it silly. Other people might find it easier. So anyways, we'll just do the next method. So again, this one's, it's as efficient as it can be. We have if it's empty, if count is equal to 1, and if there's more than one element. It seems like all the possibilities, and you may find a possibility later that you'll have to fix or add another else or if, something like that. So just the last pretty much the last method here, the last hard one. So we'll say public void Deque rear. Then we'll say if head equals to null and tail equals to null. So we could have just said if is empty, but that's fine. Oh, what's happening there? What's that? That's the class, so we'll just move that down. So if head is equal to null and tail is equal to null, so then we'll throw an exception again. Throw a new empty collection exception. Just say link deck. Then here we'll just put throws again. Throws empty collection exception. Then we'll have else. If count is equal to 1. Do we do the same thing up here? Yeah, I think we did, but we're just doing, I guess I wrote it backwards. So I set tail points to tail.get previous, which is just setting it to null again. So head then points to head.get next, count minus minus. We can just wonder if it would be better to do head or tail first, even though it doesn't matter. We'll just leave it this way. We could just say we switched it. If it causes a problem, we'll just know that we switched it. We switched it with this. So then if count isn't equal to 1, then we'll say else. So count is not 0, it's not 1. So then we'll say if it's greater than. And here we'll say linear node of generic type T temp node points to tail. Okay, so we are just adding to the tail. It seems like this one's more efficient here because we're working with the tail and not the head. We're not working for the tail, from the tail to go backwards like one of these. That one, I think. Or that one. So we're saying linear node, take make a point and object reference to tail, create a new object reference variable that's initially null, and then point it to tail. Then we'll say, so what we're doing is we're dequeuing from the rear. So then we'll say tail points to tail.getPrevious. So again, if we have 5, 6, 11, then if we're dequeuing the rear, so right now tail is pointing to 11. So we'll say, so we're saying tail and temp node points to, so tail points to 11 and temp node points to tail, which means that it's pointing to 11. So we'll say we're saying tail point to tail.getPrevious. So tail is going to move to 6. And then we'll set, so then we'll set tail dot set next to null. So this one 11 becomes null. Or tails next becomes null. There's still a previous here, it seems like. Temp node points to null, so where was temp node? So temp node was still set to tail. Or the old tail. So temp node, so tail dot set next to null, temp node points to null. Count minus minus. So again, I think there's different ways to do this. This one's efficient already, but I think there's a few ways to do this. So we could have, there's probably about 4 or 5 different ways to do this, maybe more. So we set an object reference variable to tail. Then we set tail points to tail.getPrevious, so tail points to 6 now. Tail dot set next to null. Temp node points to null. I feel like maybe in here before that we could have said because if tail moved, maybe we could have said temp node dot set previous to null. But if temp node points to null, then temp node points to null. We can double check that in the debugger, just to clear things up, if that would have helped or if it would have just been unnecessary. So again, temp node points, we create an object reference variable, pointed it to tail. We set tail, move to your tail points to tail.getPrevious. Tail, set your next element to null, and then temp node point to null. So it seems like it's already very efficient. Maybe we could have changed it another time. So here we set our object reference variable, then we set tail tail points to tail.get previous, so that's correct. Tail.set next to null. I wonder if instead of that, if we could have just said tail or just temp node equals to null over here, then would that have changed automatically? We can check in the debugger. But we know for sure if we explicitly set them that they will be set to null anyways. But we can check, we can test it. Test, we'll test that, we'll test this. So otherwise that's it. You can save that, whoops. Save that. And then now we just have the easy methods and the toString. So front, rear is empty size toString. So this method is Deque rear. So under that we'll put public T front. So we can call is empty, or if head is equal to null and tail is equal to null. We haven't wrote is empty yet, but we can just say if is empty. It's going to be asking for what it is. Then we'll say throw new empty collection exception. So we'll throw new empty. Actually, we could just return null because it's a T. So we'll say return null here. We could just print out here that it was empty, so system.out.println. Then we'll say linked Deque was empty. And we can just return null. The reason why we can return null is because this was T. The return type was T, so we can return null. Because if it doesn't return an object, then it's going to return null. So that does work. Or we could throw an exception. But we'll just do it this way. I don't think we need an else here. But we'll just write it anyways. Then we'll say return head.getElement. Then that's it. So below that we'll have the rear method. So we'll say public T rear. We can just copy this. Then we'll say else. Return tail.getElement. Then here we'll say public boolean is empty. So return count is less than or equal to 0. So public boolean is empty returns true if count is less than or equal to 0. So public int size, we'll do the next one. Public int size, we'll just return count. And then we'll just do the last toString method. So it's just going to be a traversal. So I have a few extra things in it. So we'll just say public string to string. We'll say string str equals to empty quotes string empty deck. This just says empty deck like that. Linear, then we'll create an object reference variable linear node of type T temp node points to head. Then we'll say if is empty. Return empty deck. Then else while temp node is not equal to null. Str points to str plus temp node dot get element. Plus space. So all the elements aren't just in one like number, there's a space between it. For a stack you can put a new line, and for 2D array there's something else you need to do. There's a special one for that. So then now we'll just do temp node equals to temp node dot get next. Excuse me. So str points to str plus temp node dot get element. So it's just a traversal. While temp node is not equal to null. So if we have 5, 6, 11 again. So temp node points to head, which is 5. Well, I feel like okay, that's fine. So while temp node is not equal to null, so it's a little bit different. It's not dot next. Excuse me. So we'll say str points to str plus temp node dot get element, which is 5 plus a space. So we'll just say prints 5 with space. So prints so str equals to str plus temp node dot get element, which is 5 plus a space. And then temp node points to temp node dot get next. So temp node's now 6. From the lower brace it comes back up to the condition. So while temp node is not equal to null, while 6 is not equal to null, str equals to str, which is 5 plus temp node dot get element, which is 6, but there's a space, plus another space. Then temp node points to temp node dot get next. So we'll say that temp node is now 11. Temp node was here, and then it's saying temp node points to temp node dot get next. Then ends the brace, comes back up to the condition while temp node is not equal to null. So while 11 does not equal to null, str points to str plus temp node dot get element. So the space and then 11 plus another space. Temp node points to temp node dot get next. So temp node points to temp node dot get next, which is null. Because temp node, which was 11, points to temp node, which is 11 dot get next, which is null. So temp node's next reference at this point, which was 11, its get next is null. So temp node points to null. So yeah, we said that gets 11 plus a space. Excuse me. So then we say temp node points to temp node.getNext, which is null, comes to the lower brace, comes back up, checks the condition while temp node does not equal to null. Well, it is null, so then we're just going to return str here. Whoops, not null. Return str. And that's it. That's everything. It's kind of a lot, but that's okay. It's not that much. Maybe everything, it was like 40 lines, 44 plus 7 plus 20, so maybe 250. I mean, a long code is at least like 1,000 lines, but most really long codes are probably like, you know, tens of thousands of lines, so maybe even 100,000 lines. So that's okay, that's fine. We'll just instantiate our objects. So we'll just call our methods. So we have our link deck. Don't think there's any errors. We have our linear node, which is really a doubly linear node. We have our collection exception. So we'll just go into main. And we'll say linked deck. We'll just say of integer, just to keep it simple. Type integer object. We'll just say deck, or you can say link deck. Points to new link deck of type integer object. Does it take a constructor take a parameter? It doesn't. So it's just going to be an empty link deck. So then we'll choose some methods. So we can enqueue to the front or enqueue to the rear. I guess we'll just start with enqueue to the rear. So we'll say link deck dot enqueue rear. ENQUERER. We'll just enqueue5. Then we'll copy that. We'll add 6 and 13, or 6 and 11. And then here we'll say link deck dot enqueue to the front. We'll enqueue 13. And that should be good. We might change it. Then we'll dequeue the rear and the front, and then we'll be done. So we'll create a breakpoint here, start the debugger. Just let that compile. Okay, it seems to be done. So we'll just open up our Debugger Console. So just drag it up if it's like that. You can move these windows over. We don't really need this one. We just mainly need that one, but we don't need that much space. So we'll just step into it. So right there, the button step into. So it's going to step into the constructor because here we're instantiating an object of type linked deck. So every linked deck has 3 fields: an object reference, head, tail, and then a count, which is an int. So it's going to set count to 0, head to null, and tail to null. They're already like that, I think, but that's okay. just to put something in the constructor. Then we'll say link deck.enqueue. We're going to add 5. So 5 is a parameter. So we create an object reference variable here. So we're going to create a new node. Actually, we're going to instantiate an object, not just a reference variable. So we're going to create a new linear node object of type T. We'll call it node and pass in element, which is 5. So it's going to set element, previous, and next. So here we have our node. It's at memory location 956. If head equals to null, so we can check that by clicking this link deck. So head points to null, that's true, and if tail points to null, that's also true. Head points to node, and tail points to node, so the head and tail are both pointing to the same node. So so in a queue or a deck, they point to, so both a queue and a deck, the head and tail reference point to the same place when it's null, or if there's one element in the queue. So that could be a test question. So head points to node, tail points to node, so we should see that head and tail both point to memory location 956. And that's just the element, so it has its own memory location for the element. Excuse me. It's 954. You don't really need to look at that. Just know the head and tail memory locations are pointing to the node memory location, which is 956. And it's holding the object 5. Could have said TOBJ here, but we just said element. OBJ works good too. So count plus plus, so count's going to become 1. And that's it, because it was empty, and it was just kind of a simple enqueue because it was null. So head pointed to the node, tail points to the new node, count plus plus, that's all you have to do. So we'll enqueue the next one rear, which is going to be different now because there's something in it already. So step into that, and we'll create a new node object, pass in the element 6. Then if head is equal to null, so is head equal to null? It's not, because head points to memory location at 956. And then it says, so that's false, and then and. It's already going to be false because there's an and here, but we'll just check the other one, and if tail is equal to null. So is tail equal to null? It's not, because it's pointing to memory location 956. If there was an or here, we would have to check both, but it's an and, so the compiler just checks the first one and it just goes to the next thing. So that's going to be skipped. That whole block to that brace is going to be skipped. So else, create an object reference variable pointed to head, which is memory location 956. Memory location 956, which points to our node right here. We have a new node actually. So our new node's memory location at 989. It's holding the element 6. So we'll say linear node, temp node point to head, the previous head, or the same head. So 956 points to the previous node, which was at memory location 956, holding 5. So we're going to step into that. It's going to set temp node to point to 956, which is head, So while temp node dot get next does not equal to null, while temp node, which points to head, the head node, which is 956 memory location, while temp node dot get next does not equal to null, well, temp node's next is equal to null, so that's going to skip. Then node, our new node, set your previous reference to temp node. So our new node, which is at memory location 989, set your previous pointer to temp node, which is the head element. So node, excuse me, set your previous reference, which is null right now. Sorry, node, set your previous reference to temp node. So where's node? Node's here. I'll just collapse these. So node, the new node we just created holding 6, set your previous reference to point to temp node, which is pointing to head. So right here we have our node, and its previous reference points to memory location 956. And then it's going to say temp node, take your next reference, so it's going to point to the head node, take your next reference and point it to, take your next reference and point it to the new node. So it's saying head temp node, which is pointing to the head node, the first node in our deck. Take your next reference and point it to the new node we just created. So now we have a doubly linked deck, or we have two links now, one pointing back and one pointing forward. Then we'll say tail, change the tail and point it to the new node. So tail, point to the new node, which is right here, holding 6. So now head's going to be pointing to memory location 956, I think. Here we go, we have head pointing to memory location 956. Its next also points to 6, so you can check different places here. So memory location 956 holding the element 5. Its previous is null, of course, because it's the first element, or it's the first object in the deck. Just like tail's next is going to be null, but here its previous is null and its next is pointing to the next memory location 989 holding 6, so that's all correct. And then you can see its next reference here is pointing to null, and its previous is also set to point to the next one. So it can actually just keep going like that forever, I think. So that's a little silly, I don't know why it does that, but it just goes in a loop basically. Is that stored somewhere? I hope not, because that would be taking a lot of memory. Just again, you can see head, and then we have tail. Its previous points to 956, which is 5. Its next points to this one, so it kind of looks like it's going in a loop if you click them. See, what I mean by that is we have our tail here, element pointing to 6, memory location 989. Its previous points to head, and then it also says, okay, well, the head's previous reference next points here, and its next reference points here, its previous points here, its next points there, previous points here, next points there. It just seems like it's going in a loop here unnecessarily. But I guess you're asking for information, it's returning it. So we'll just collapse all that. And then count plus plus. So then we'll NQ to the rear again is going to do the exact same thing. So can we stop that? Excuse me. So we'll move that bracket down here. Sorry, the breakpoint. We'll take this and we're saying, can we change it? Or we can leave it like that and change it at the end. Might be better. So we'll just skip that. It's going to do the same thing, so we'll go into this. So I moved the breakpoint down and then I started the debugger again. So we'll step into linear node of generic type T node. So we're going to create a node with an element. We'll step over it. So if head and tail equal to null. So they're not null, they're pointing to memory locations. Tail should be 11 yet. So skip it. So linear node temp node sets a reference to tail. Okay, so it's going to traverse from the back again. It's a little silly, but that's okay. It works. So we'll say while temp node dot get previous. So temp node points to tail. So temp node points to 11, memory location 985. So while temp node, which is pointing to memory location 985, the last element, right here, tail, does not, its previous does not equal to null. Temp node points to temp node dot get previous. So temp node points to now 6, I think. So temp node points to 6, and then while temp node dot get previous, so we'll click on temp node, its previous is not equal to null, which is true. Temp node points to temp node dot get previous. Temp node points to temp node dot get previous, so temp node's going to point to 5. So temp node now points to 5. You can see, well, temp node dot get previous is not equal to null. Well, that's false, so it's going to skip. So node set your next, so the new node that's still floating up here somewhere, right here. We'll collapse that. We'll say there's a node waiting, the 13, to go into the queue. So we'll say node, take your next reference and point it to temp node. So go behind. Actually, sorry, technically go in front. Yeah, go in front. So if the nodes are aligned left to right, it's actually, I guess, yeah, go behind it and set your next to temp node. So it's like, should I draw it? Do a little diagram here. So 5, 6, 11, 13. No, we just have 5, 6, 11. So 13's floating out here. It hasn't linked with hasn't formed doubly links yet. So it's like, okay, node, take your next, I set it to temp node, so it's like, okay, go behind temp node and set a next here. And it's saying, okay, temp node, which is pointing to 5. Take your previous reference and point it to node, so there we have a doubly link like that. Instead of commas, they're all doubly linked. So there we go, we got a next and previous reference for both, doubly linked like a chain. So that's fine. So node, set your next reference to 5. There you go. And then temp node, set your previous reference to temp node. Set your previous reference to the node. There we go, temp node's previous points to 13. Now head points to the new node, so where's head? Head is here, which is pointing to 5. It's saying, okay, head point to now the new node, which is 13. Here you go, head points to 13 now. Just remove these and then check this. Link deck head points to 13. Count plus plus, is that right? Count is now 4, that's right. That's done. So we'll stop that. We'll DQ 1 from the front and 1 from the rear. So we're almost done. And then we'll try to change those just to make those more efficient. Just to see if it works. So we will DQ from the front first. So DQ front, no parameters. So link deck dot DQ front, like normal. I queue DQs from the front. Whoops, sorry. Moved the mic by accident. So we'll set a breakpoint there. We'll start debugging. So hopefully you are understanding this. It takes a while to kind of understand it. You may have to practice this like maybe 5 times. Write the code 5 times, use a debugger, and then eventually you'll get it. I'll also try to do the diagram on this. The diagram will help you see the nodes changing. That helps. That pretty much what I needed to see to learn it. So here we'll say we'll just step into it. DQ front. So right now we have what is our deck looking like? So we have head. Okay, so head's 13. So 13, 5, 6, 11. Something like that, and they're all doubly linked. What happened there? Oh, I forgot how to fix that. Okay, I had to hit the insert. There we go. Okay, so 13, 5, 6, 11. I think that's what we have. So head is 13. Its previous is null, that's right, because it's the first element. Its next is 5, that's right. Its previous is 13. So 5's next is 6, that's right. 6's previous is 5, that's right. So 6's next is 11. That's correct. Its next is null. Whoops, what happened there? Just collapse that, it glitched out for a sec. So this head 13, previous is null. Its next is, whoops. So 13. So head, its next is 5. Its next is 6. I just want to run through that again just to double check. So we have our head element 13, which is a head element. Its previous is null. its next is pointing to 5. Its previous is 13, that's correct. And 5's next is 6. That's correct. Then its previous is 5. That's correct. Then then 6 is next. 6 is next. Reference points to 11. Its previous is 6. That's correct. And 11's next is null. So it's working. So we're gonna deque from the front. Why is it pointing here? Okay, we'll point there. If head is equal to null and tail is equal to null, well, that's false because they're not null here. So if count is equal to 1, that's false because count is equal to 4, so that skips. So we'll say linear node set a object reference variable to point to head. Head points to head.getNext. Head points to head.getNext. So temp node points to head, temp node, do we skip that yet? No, okay, we don't. So step into, temp node points to head, there we go, 13. So maybe I should just draw this down here. So temp node points to head, so it's here at 13, which is also head. Tails here. So temp node points to head, which points to 13. Head points to head.getNext. So head points to now 5. Head points to head.getNext, so head, yes, so head's here. We can double check that, so right now head's pointing to 13, we'll step into head now points to 5, that's correct. Then we'll say, okay, head, your next is 6 and your previous is 13. Set your previous to null. So head, your next is 6. Your previous is 13. So set your previous to null. Done. So we'll collapse all that. So head, your next is 6 and your previous is null. So the first element is basically gone. Temp node, which is still floating out there, we'll set it to null. Count minus minus, so our new linked list, sorry, our new doubly linked has this removed. 5's ahead, 6 and 11, so we should just have those elements, so 5. So we can see here in our linked deck we just have 5, 6, and 11. I think that's the toString being printed out to us in real time. It's printing the object data instead of the memory location hash code stuff, so we'll just click this to check, so tail points to 11. We can just check backwards as well. So its previous points to 6 and its next points to 11, that's fine. Its previous points to 5. Its next points to 6, that's right, and then since 5 is the first element, its previous is null. That's correct, so from the tail it's fine. We'll check from the head, so head, your previous is null, that's right. Your next should be 6, that's right. Your previous should be 5, that's right. Your next should be 11, that's right. Your previous should be 6, that's right. Your next should be null, so it's working. Count minus minus. Didn't we say we wanted to change something here? So linear node, temp node points to head, head points to head.get next. Head.set previous and null. It works. I mean, you could try different things. That seems like the best way to do it. I think you could. It seems as efficient as it can be with regards to time complexity. So there should just be a O of 1 change, big O of 1 time complexity, because they're not traversing at all. It's just moving one shift. It's just shifting by 1. So I'm thinking if we could just maybe set temp node to null head. No, I think that's the best way. I mean, there's no point in really trying to fix it. So we did Deque front. We should have one more to do. Deque the rear. Okay, we'll Deque the rear, so we'll stop that. I think this video might be almost 2 hours. That's okay. So we'll do link deck dot Deque rear. We'll set our breakpoint, and then we'll start debugging again. So we have 5, 6, and 11. It's showing us there. So we're going to remove 11. So we're going to step into it. So if head equals to null and tail equals to null, that's false. If count equals to 1, that's false. So linear node, temp node, point to tail. So tail here. Point to tail, which is 11. So maybe I should just write this out again. So we have 5, 6, 11. And we have tail pointing to the end here. I guess we have doubly links, so we'll just do it like that. So 5, 6, 11. Tails at the end, heads at the front. So then we have tail pointing to tail.get previous. Actually, no, sorry, we have temp node pointing to tail, so we'll just say temp node points here. Points to tail. So think of it like this: arrow going to tail, tail going to 11, so it has a direct link to 11. Tail points to tail.get previous, so tail points to tail.get previous. Tail points to tail.get previous, so tail is now 6. And then again, that object reference variable still has a direct link to 11. That's because it was set before. Now if we set it to tail now, so if this was commented out and we put it after this line here, below this line, then it would be pointing to tail. So that's something you should definitely know. So we haven't actually clicked. I know we haven't clicked this yet, so we'll step into. So right now there's no temp node. Step into temp node points to 11, or tail. Then we're going to say, okay, tail, point to tail.get previous, so just collapse these for a sec. So temp node points to 11, tail. They're both pointing to memory location 984. So it's saying, okay, tail, take your tail and point to your, whoops. So tail, tail equals to tail, Deque previous, so point to your previous reference, which is 6. So tail moves over here. We already did that in the diagram. And then we'll say, actually, whoops, yeah, we have to click that. So right now tail's pointing to 11. Now tail should be pointing to 6. So then we're saying, okay, tail, set your next to null. So tail, set your next reference, which is still pointing to 11. Set it to null. Because tail has shifted, there's still a link here. It's still linked. We want to remove 11, so we're going to try to set its tail's link to 11 to null. So now if we click tail, we'll see that its next reference is null. And temp node probably still has a reference to 6, so we're going to delete that too. So then we'll say temp node, we're going to set temp node to null. Temp node point to null. So temp node still has a memory location to @984. So that's going to just be set to null. That was our pointer. And count minus minus, so that's going to change, so we can just double check. So we removed the last element here. So we just should have 5 and 6. It's showing us that here in our link deck. So our head points to 5. Its next points to 6. And its previous points to 5, so that's working. We check from the back too, so tail points to 6. Its next is null. Its previous is 5. So is our head previous null? Yeah, it is. So that's working. We can stop that. And there's a few things we wanted to check. 3 things, I think. So can we change this? So temp node.set previous. Temp node gets set to null, so I feel like this is unnecessary. It probably will do the same thing. But that's just explicitly setting it so it doesn't hurt. And then, so we can run it with that and get the same result probably. It should be the same thing. So step into, step over, step over, step over, step over, step over, step over, step over. So we should have the same thing here. 5, so 5 and 6. The head's next reference points to 6. 6's previous points to 5. It's working. Head's previous is null. That's working. So tails next points to null. That's good. So tails previous points to 5, and 5's next points to 6. So that's working. It did the exact same thing. We can stop that. We can comment that out for a sec, and we can just comment this one in. I feel like it's you can check. We can check it, I guess. So we'll just say what we'll do is we'll take that out, put that here, comment that out, comment that in. We'll just say we swapped this for this in the meantime. Test swapped. Swapped, we'll just say swapped. We'll just say swap this with this. Okay, so we'll run it. I feel like this isn't gonna work, because we just have the same thing twice. So skip. Temp node points to tail. Tail points to tail.getPrevious. Yeah, so it didn't change. So we have this pointing to 5, tail pointing to 6. Its next points to 6 and its next points to 11 though, so there's still links there. So we can conclude that did not work. So what do? We just swap these. I'll just Control Z it. Do we have that? Yeah, we did actually. So this, it works fine with this. It works the same with the previous explicitly set and not. So it doesn't hurt to have that line, just to make sure you're setting it, so we can conclude that doesn't work. This works. Might be better to explicitly do that. And then we had two things we wanted to change. So we wanted to get rid of all that code and just put in a simpler statement, so we'll just do that here. So we will take okay, so what are we trying to do here? We're trying to take out all this stuff and just put these 3 lines. Is that all we're trying to do here? Okay, so we were, instead of traversing, right? So do we still need this? Tail.set next to node. Is that all we need? Excuse me, tail equals to node, so that one stays. Node.set previous to tail. So we're going to comment this all out. So to do that, you just, how did I do that? So you highlight it. I think it's Control and then the comment button, the slash. That comments it all out. So we don't need that pointer, don't need that while. We just need tail.set next to node. So we're enqueuing to the rear, so we're just saying, okay, tail, set your next reference to the new node. And it's saying, okay, node, set your previous reference to tail. Then it's saying, okay, tail, redirect yourself and change to the new node. So hopefully with all that, it should work. So we'll check enqueue rear, enqueue rear. Here we go, so we'll step into that. It should work. Actually, the first one doesn't even hit that statement, does it? Intellij asking me to update. No, I do not want to update right now, so we'll step into I don't think it's going to hit those statements at this time. So it just creates a new node. If they are true, set it. Done. Right. So then now we'll check if it works. So create a new node. Actually, I'll make this a little bigger. So create a new node, linear node of type T node. Set it to new linear node. Step into creating a new node. Memory location 989. Holding 6, as we already have 5. So this is going to be false. So it's going to say tail. So right now tail is pointing. So we have head 5, tail 5. Okay, so it's saying tail. Set your next reference to node. So tail, set your next reference to the node 6. And it's saying, okay, node, set your previous reference to tail. Node, set your previous where's node? Set your previous reference to tail. I think this works. Whoops, remove that. So node, set your next. Node, set your previous to tail, which is 5, and it's saying, okay, tail. You don't put to 5 anymore, you point to 6. So that's okay, we have 6 is tail, 5 is head. That's working. Head points to 5. The head element, memory location 956. Take your next reference, point it to 6, that's working. Its previous points to 5. Is that working? So its next is 5. So the head element points to 5, its next points to 6. Its next is null, that's right. Its previous is 5. Its previous is null, so its head's previous is null, that's working. So we'll check from the tail. So tail, your next reference is null, that's correct. Your element is 6 and your previous is 5, that's correct. 5's previous is null, that's correct, and 5's next is 6. So yeah, that works. So that's more efficient. We're doing it again. Okay, so we'll step into it. I'm just gonna skip it just to see if it did work. So we have we're adding 11. We said tail, set your next. Tail, set your next to node. So we have head 5. Its next is 6. Its next is 11. Its previous is 6. Its previous is 5. That works. So we'll say head's previous is null. Tail's next is null. Tail's previous is 6. That previous is 5. So it seems to be working. So we'll stop that. And then we wanted to change something else. So honestly, we can just delete this. If you want both versions, you can just pause the video and create 2 versions. So then here we'll create so what are we doing now? We're changing this code, okay. So node, so we're enqueuing to the front. So node set your next to head. So again, we're not going to need any of this here. Head's going to point to node, same thing. Head.set previous. Okay, so this is all going to be commented out. So we're going to say node, new node. So what we're doing, we're enqueuing to the front. So new node, set your next to head. Whoops. Okay, what happened there? So node, set your next to head. Head, set your previous to node. Head, redirect yourself to the new node. So it's saying, okay, node, set your next to the head. Head, set your previous to node. Redirect yourself. That should be working. So we'll just test it. So we'll enqueue to the front. That's what we're doing. Enqueue front. So we'll just step into that. So we've added 5, 6, 11. We're going to add 13 to the front. Okay, sorry, I zoned out for a sec. So we'll say link deck.enqueue front. So we'll step into that. We'll create a new node. We can skip that. We can just step over it. So we have our new node here, memory location 987. Has the element 13. So if head and tail equal to null, that's going to be skipped. So it's saying, okay, so right now we have 5, 6, 11. You just double check. Head's 5, its next is 6, its next is 11, its previous is 6, its previous is 5, its previous is null, so that's working from that side. Check the tail. The tail's next is null. This previous is null. Yeah, okay, so tail's next is null. Tail's previous should be 6. That previous should be 5. That previous should be, so that seems to be working. You can double check it. But we'll just say node. So node here, set your next to point to head. That's all it's doing. So we're gonna create, so right now the node 13 is like floating out somewhere. So it's saying, okay, link yourself to the head, set your next link to head. So it should have changed here, so node, set your next now to point to head, which is 5. And it's saying, okay, head, take your previous reference and point to node. So node, take your previous reference, sorry, head, take your previous, where's head? So head, collapse that. So head, there's also that one there. We'll check from the instance data, so head, take your previous, which is null, and point it to our new node, which is 13. So head's previous points to 13. So now it's saying, okay, head, redirect yourself to point to 13. So now we have head pointing to 13, so I'll just collapse it. So, whoops, not node. Head, should be pointing to 13, its next should be pointing to 5, its next should be pointing to 6, its next should be pointing to 11. That works. It seems like it's working. Its previous is null, so head's previous is null. Whoops, what happened there? So head, your next is 6, sorry, your next is 5, its previous is 13, its previous is null. So from the head it seems to be working, from the tail is 11, its next is null, its previous is 6, its next is 11, its previous is 5, its next should be 6, its previous is 13, its previous is null, so it works. So that should be all. So we've made it more efficient. We've tested it to see if it works. These are all efficient. You can test size is empty, should be working. Rear should get your rear, and front should get your front. So I hope that helps, and I'll see you guys next time. Take care.